Basic set concepts. In this section, we're going to talk about the sets. We are going to discuss three different ways to represent a set. We're going to talk about the empty sets. We are going to talk about these two notation. We're going to use set notation for natural numbers. We're going to talk about cardinal numbers, equivalent sets, finite versus infinite sets, and then equal sets. These are the objective. So a set is a collection of objects whose content can be clearly determined. So it could be a collection of anything which is well defined. You have to say collection of what? For example, let's say collection of numbers from 1 through 5, collection of natural numbers. So this is well-defined set. Okay, and these members of the set is called either they are called elements or members. This must be well defined. If it's not well defined, if I just randomly use things or elements, then that is not a set. Okay, the order doesn't matter, so I can write down the very same thing differently. I can say it's 1 5 3 2 4. Still, these are the natural numbers from 1 through 5. That's how I can well define. How can we represent sets? There are different ways. First of all, we use capital letters. For example, this one I can say that this is my set of natural number from 1 to 5, and I can denote this as a capital letter. That's for the set. We can also describe set in word description. For example, the very same example I was giving before. If I have to write down the word description, I would say this is the set of natural number from 1 to 5. And if you list the member or elements of the set, that's called roster method. For example, here W is a set of days from Monday through Sunday, all the days, all 7 days: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. We normally use comma to separate the elements. We use this braces to denote the set. So that's the one way to represent sets, using in a roster method. Description way, word description, that's another way. And then third one is the set builder notation. This notation is called set builder notation. For the very same set, W is the set of all elements X. But what is X? We're going to define that such that this separator is called such that X is a day of the week. So how many days are there? 7 days. So what is the value of X? X could be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So this notation is called set builder notation. Okay. We might have empty set. Empty set means nothing is there, and we use this two notation to denote the empty sets. For example, set of all number less than 4 and greater than 10. You are trying to find a number which is less than 4 and greater than 10, but that's not possible. So there is nothing which is less than 4 and then greater than 10. That's supposed to be true for both of this. For example, let's say, pick something from here. Let's say 0. 0 is less than 4, but 0 is not greater than 10. So 0 is not part of that set. So this type of set is empty. Nothing is there. These are the notation we use for, let's say, A is a set of natural number from 1 through 5. Then 1 is a member of A. This is how you write. 1 belongs to A. 1 is a member of A. So this symbol means it's element. 1 is an element of A. If something is not element of A, for example, 6 is not element of A. 6 does not belong to A. So either you can say this as a belong or is an element of, and this as a does not belong or is not an element of. This is how we denote the set of natural number. N is a set of natural number from 1 through, keep going. This dot 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 means keep going, keep continuing. We can write down the inequality into set notation, set builder notation, or roster method. For example, let's say x is less than A. You can write down the very same thing. X is the set of natural number which is less than 4 in this example. How do you show that? How many natural numbers are there which is less than 4? 3. 1, 2, 3. X is less or equal to 4, and then x is natural numbers. So this is the set builder notation. 1, 2, 3, 4 are the 4 natural number which is less or equal to 4. And then similarly, x is the natural number, x supposed to be natural number and greater than 4. So all these numbers are natural number and greater than 4. So this is how we can write down inequality into set notation using roster or set builder notation. Next is cardinal number. Cardinal number means the number of elements in the set, any set, without repeating anything. For example, A is, let's say, 1, 2, 3, 4, 5. Then cardinal number of A is 5 elements. N of A. The symbol NA is called N of A. Repeating elements in a set neither adds new elements to the set nor changes its cardinality. Two sets are called equivalent if their cardinal number are equal. For example, let's say two sets, A, which is sets of vowel A, E, I, O, U, and B is sets of natural number in between 3 to 7, including 3 and 7. So both of them have the 5 elements. So they are equivalent. They are not equal, but they are equivalent. Equivalent means same number of elements. So how do we write? A is equivalent to B. So both of them have the same number of elements. Okay. So there is, you can see the one-to-one corresponding between two equivalent sets. Two sets are not one-to-one corresponding if their numbers, total numbers, are not equal. If the cardinal number is finite, then that is called finite set. If the cardinal number is infinite, then that's called infinite set. So for example, let's say A, 1, 2, 3, 4, 5, that is how we define. B is set of natural number, all natural number. Since the cardinal number of A, the cardinality of A is 5, finite set. Here you have infinite number of elements in B, so B is infinite set. Two sets are called equivalent if both of them have the same elements. So A and B are equal. They are also called equivalent. Sorry, equal. So both of them has to have same elements. So A is 1, 2, 3 and B is 1, 2, 3. Then they are equal. Okay. Let's look at some examples. Fill in the blank so that resulting statement is true. The set California, Colorado, Connecticut is expressed using, what is this? It's the roster method. And the set of X such that X is a US state whose name begins with the letter C. This is called set builder notation. Okay, there are 3 different ways to represent a set. Set roster method, set builder notation, and description method. The number of distinct elements in a set is called distinct element. The number of distinct elements, that's the cardinal number of the set. If A represents a set, this number is represented by N of A. That's the cardinal number. Two sets that contain exactly the same elements are equal. exactly the same elements that's supposed to be equal. Write a description of the set. There are 3 months, January, June and July. The set of months that have more than 3 letters. The set of months that begins with J. Yeah, that looks good. Express the set using the roster method. Set of x such that x is natural number. This n represents natural. And it has to be greater or equal to 9. So how do you write it? You start with the 9 and you keep going forever. So 9, 10, 11 and dot dot dot. Determine if the set is empty set. The set of x such that x supposed to be less than 2 and greater than 8. There is no number which is both. So the set is empty set. The set is the empty set. Determine whether the given statement is true. 3 does not belong to this set, but that's not the case. 3 is here, so that's false. A set is the set of A is the set of states in the United States. B is the set of state mottos of the state in the United States. Are the sets equivalent? Explain. The sets are equivalent because they have the same number of they contain the same number of elements because there is one motto for each state. These sets are not equal because they have different elements. They don't contain the same number of elements. They don't contain the exact same elements. A study of 900 working women showed that their feelings changed throughout the day. The line graph shows 15 different times in a day and an average level of happiness for the woman at each time. Based on the information given by the graph, we represent the set using the roster method. X, the set of x such that x is the time of the day when 3 less than average level of happiness less than 4. X is the time of the day when 3 is less than average level of happiness. X is the time of the day when average level of happiness is in between 3 and 4. Average level of happiness is supposed to be greater than 3 and less than 4. So greater than 3, this is the average level of happiness. Greater than 3, look at here vertically, 3 is here. Greater than 3 starts from here. Greater than 3, so that means 19, greater than 19, and then yeah, greater than 19. Time of the day, 19 means 7 p.m. Choose the correct answer below. It's more than 7 p.m., which is, what is the answer? This is the level of happiness, right? On the left side. It's greater than 3 when you have 20, 21, and 22. These are the time. 20 means 10 p.m., 11 p.m., and 12 p.m. So 20, 21. Where is that? I don't see it. X is the time of the day when average level of happiness is greater than 3 and less than 4. Oh, less than 4 as well. These two are equal 4. So the only time of the day where it is greater than 3 is and less than 4 is 20. So 20 is the answer. Okay? That's all for this section.